Hello, everyone, and welcome to today's workshop. We are talking about NoSQL databases with our introduction to NoSQL databases. I am Ryan Welford, and I'm joined by Cedric Lundvin. Hello, Cedric.
Hello, everyone. Happy to be here with you for this 2 hours introduction to NoSQL. So we will have a good time today all about interactivity.
Yes, if you can hear us and see us just fine, give us a thumbs up in the chat. Just make sure that everything's working correctly. And we'll go ahead and get started. As I said, I am Ryan Welford. I'm a developer advocate here at DataStax, and Cedric is our director of developer advocacy. And you can see some of our stats up there on the screen.
Yeah. I created just a framework a couple of years ago, FF4J,
Just a
and
small
here
one.
you do have my feature toggle. And you do have our coordinates, LinkedIn, GitHub, and Twitter. So go ahead, invite us in your network. Always happy to connect.
All right.
Okay.
Looks like we have some thumbs up, which is great. I'm glad that everything's coming through just fine.
That's check. Okay, check. Sound is okay. Let's get rolling. No, that's really important. It's not only me and Ryan on screen. So the whole team of advocate is with us, helping to answer your question in the chat right now. So thank you to all the team to be there with us today. A little bit of housekeeping. So we are live on YouTube. I think we do have the backup live as well on Twitch, but we only monitor the question on YouTube live, not really Twitch. Twitch is just a backup. And we also have a Discord room. You can ask your question there. Discord is great because when the live is done, you cannot reach out to us with YouTube anymore. You need to switch to Discord and ask your question there. We will be there all week long to answer your questions. We will do a little bit of hands-on today. As usual, as any workshop, everything is on GitHub. The code, the instructions step by step, the exercises, the slides, the data set, whatever you need to complete the exercises. You don't have to install anything, but still you will work with NoSQL database. What a surprise. At the very end, I will do a demo if we have time about a graph database using Docker. So this one would be, push as homework for you to do. I don't think we will do it live. I mean, you will do it live. So TLDR, nothing to install for you. As for every workshop, there is no certificate just to attend the workshop. Okay, but at the end, we ask you to do some homeworks. Yeah, real homeworks. Now it's easy, really, just populating a few questions in the form, uploading a screenshot, just showing you have completed the step of this session, and we will give you this nice badge, part of the collection. So if you want to have more badges, look at the YouTube channel, browse our multiple workshops on multiple topics. If you want to not miss what's coming, datastax.com/workshop. And yeah, so happy to have you today. Let's have fun. Today is really for beginners, introduction to NoSQL database. So no prior experience needed. So let's relax. I told you the workshop is all about interactivity. We will ask you question live, okay? And we will start with that. To be honest, I will ask you a few questions right now. Nothing at stake, okay? For now, it's just a few questions to know you a bit more. But at the end, we will reuse the same tool and we will play a game all together. And if you answer the question correctly and fast, the 3 fastest among you will get some free swag shipped to their location. To play the game, pretty easy. Open a new tab in your browser, or if you are on your phone, scan the QR code that will be shown on screen. If you pick the route, open a new tab, go to menti.com, enter the code 89 14 26 17. Also, you can enter the code in YouTube chat, like !Menti. I've seen that Ryan already did it, to get the link to go there. And I will wait for you there. So we are almost 200 live now on YouTube. So I would expect you to join these quiz right now. So as of now, I see 6 people, and I will wait for you to come. So open a new tab, menti.com, use the code, or use the QR code, or use the link in YouTube chat. So 3 ways to go to Menti.
Yeah, I don't know if you mentioned this, Cedric, but this is a way to kind of get to know kind of your level of experience and where you're coming from, so that we can make sure that we address you know, any questions that might come up, and we can get you started on the content that we have.
Totally. So I see. Look at that. 45, 47. Hey, here you go. That's great. We will have a great game at the end, you know. With so many people playing live. Okay. So let's wait. You know, I would like to have, I don't know, 70, 80. It's still going up and fast. So the session will be 2 hours. It's recorded. So if you feel that we are going a bit too fast for you to keep up and do the exercises with us, do not worry. It's recorded. You could do later, do the exercise at your own pace. And, you know, we will still be there on Discord to help you if you have questions. Look at that, 80, 85. Keep, you know, you know, I won't wait too long, but it's still rising. Okay, 1 more minute. Can we reach out to 100? Oh, you can see it on screen just below me, but I do have some counting just showing up on screen. Okay, for Mohammed, the code is really on screen, very at the top. So 95, 80. 89, 14, 26, 17. It's really at the top of the screen. Look at that, more than 100 with us. That's great. Okay, so again, in the beginning, nothing really at stake, just quiz to know you a bit more. So let's go. I think we do have 2 or 3 questions in the beginning. So question number 1. So which role describes you the best? Are you a student, a backend developer, a front-end developer, administrator, data architect, or another? Oh, see, like we do have a lot of students. That's great. Come here to learn. Super cool. Yep. Backend developer, all good. Front-end as well. Yeah, NoSQL is important to everybody. Wow. Okay. See, fair enough. Pretty, you know, even distribution. That's cool. Bunch of data architect as well. So that's great to see. The session is intended for beginners, so you are in good position. Okay, now what about your time zone? What about your location? Where are you? Do we have a lot of people working late at night, in the morning? Let's see. I'm based in Paris, so just, you know, in the middle. For me, it's 4 p.m., 4:40 p.m. That's cool. So look at that. So many, a lot of people from India today. And it's not only today, it's as usual. Thank you for being with us again.
Awesome.
All right, great. Okay, keep moving. I see that I still, yeah, I can see people still voting. All right, great. Okay, keep moving. Next question is, are you using a NoSQL database already today? Hey, document-oriented database. Seems like we have some MongoDB user, probably.
Most likely.
We have seen some front end in the audience, so yeah. No SQL. Sorry, I have no idea. That's totally cool. You are in the good place at the good time to learn about all these. Oh, we have also some multi-technologies. So I totally expect you to challenge us about which one is doing what, which one is better. Yeah. So please try to answer in Menti. For now, not a big deal really, just a bunch of statistics. But at the end of the workshop again, we will play a game together. And if you answer in Menti, you can win the swag for free. Oh, I see now 125 in Menti. That's great. So again, Raghavan is in the YouTube chat to help you to reach the Menti. Okay, next question. Need to change focus. Okay, have you attended one of our workshop before? Okay.
A lot of newcomers.
Oh yeah, a lot of newcomers. So welcome. Hope you will enjoy the content, the format, the interactivity, the energy, and even the speaker eventually. If you like the content along the way, don't hesitate to subscribe to the YouTube channel. Make us coming back every single week. So we are doing those workshops twice a week, every week. We will go on hiatus for 2 weeks for Christmas. But I think this workshop is about more than 110, 120-ish. So look at the YouTube channel, plenty of content covering a lot of topics or a lot of newcomers. So Ryan, we need to be pretty sharp and good today. With so many newcomers, we want a lot of new people in the community. Okay, thank you for these. Last question I do have for you. Oh no, I think do 2 more. How many NoSQL database exist? What do you think? Today's introduction to NoSQL database. How many? Oh, less than 10? No. We will probably cover 20. I will give you 20 names today. So probably about 20 names. So yeah, it's a bit more than yes. So the answer is surprisingly hundreds. I would have said dozens, but if you look at all the listings available, it's hundreds. That's just crazy. Some are really not really used, of course, but yeah, there are a lot of NoSQL database out there. And like a question at the end of the session, you must know the answer. So right now is, are NoSQL databases schemaless? Yes or no? Yes or no? It depends. Yes or no? It depends. Okay. You know what? I won't give you the solution right now because hopefully you will pay attention about what we say and do stuff with us and realize by yourself if it's schemaless or not. Okay, so cliffhanger here. And now it was our last question. So don't close this window. Again, we will come back right here at the end to play a game all together and make you win some swag. Okay, but for now, let's do a little bit of theory with me, and very soon you can get some hands-on. Speaking of which, should we start the hands-on right away? Maybe we can, just to initiate the database, right?
Yeah, I think that's a good idea.
Okay. So right. Okay, so I will hang over to Ryan just to do the first step. The first step is really instantiate your database to be able to do the exercises later. As the database will take a few minutes to initialize, let's start with that, and we won't lose time. During the initialization, we will go back to slide and do some theory.
Yeah, so I just put a URL in the chat that you can click to go to set up the Astra database. So we're going to be using the DataStax Astra DB for our database today, which is a NoSQL database, and it will allow us to kind of represent a lot of different styles of databases in how it works. So that's what we're going to do. Let me switch over to my screen. So you can use the link. I think there's a link in the description of the video, and there's also links in the chat that you can use as well.
Yes.
Let me make sure that those are in the Discord as well. Okay.
Yeah. Yes, that's the link for. Yeah.
I'm also working out of the GitHub repo that you can see on the left side of the screen. And so there's also a link in there that you can use to get to Astra. But when you follow that link, you'll come to a page that looks like this. And you can sign up with Astra using a GitHub account, a Google account, or with just a regular email and password. That's all the information that's needed. You don't need a credit card to sign up. You don't need any other information. It is completely free to get started. There might be a survey question that they ask you, and you can choose the education option, which is totally fine. So I'm going to go ahead and sign in with Google. I'm going to have to refresh my page. There we go. And considering that most of you are new, I will go through the setup for new users. If you have been with us before and done one of our workshops, you might already have a database called Workshops. Let me zoom in here.
Please.
You might already have a database called Workshops. We're actually going to use that same database and just create a new key space, and I'll walk through that process in a little bit. But for those of you, the majority of you who are new, I will go through the new database setup. So once you create your account, you'll see a page that looks like this. This is your dashboard. You won't have any databases created, but you can click on this button on the left side called Create Database, and it will bring you to a page that looks like this. And we just need to give it a database name and a key space name, and we have those specified in the GitHub repo. We really recommend using these names because a lot of the information in the GitHub repo that we can just copy and paste without having to type so much assumes these names, so it just makes it a lot easier. So we're going to create the database name called Workshops, and then the key space name will be NoSQL. Now, what is a key space? A key space, if you're coming from a relational world like a SQL database, a key space is like a schema. It's a collection of tables. Sometimes they're called namespaces as well.
Mm-hmm.
But it's just a logical collection of tables. And then for the provider and region, you can select whatever provider you want. You don't need an account with this provider. Astra will handle that for you. And for the region, you can just select a region that is closest to you. So I'm going to go ahead and choose US Central. And then you'll go ahead and click Create Database, and it will create that database for you. It'll spin up that 3-node cluster.
And as you can see, there is no credit card ask or anything. It's a free to use, and it's free to use as long as you are not doing 30 million queries per month. So, that won't be the case today or even tomorrow. So that's a pretty generous free tier. You can use it now, and you can also use it at school for your own project. It's free for 30 million queries a month.
Yeah, and as you can see, there's a section for credits remaining. Everyone will get $25 of credit every single month, refreshed, and so that's kind of how it's free. So if you already have a Workshops database like I do, because you've been to one of our workshops, welcome back, by the way, you can go ahead and click on that database, and if you scroll down, you can see the key spaces you have, and there's a button above the key spaces called Add Key Space. And I'm going to go ahead and click that, and I'm just going to enter in the new key space name, which in this case is NoSQL1. And that's how we're going to add a new key space, and that's all we have to do if you already have the database created.
Yes.
So once you create your database, on your dashboard, you will see that there is the status will change, or if you have just created it, it'll probably be in pending. It'll just take a couple minutes to turn to active. And so while we're waiting for that, I'm going to hand it back to Cedric to do some slides.
Yeah, let's pause just a few seconds, just for you to give us a thumb up in the chat to say, okay, I was able to enter the parameters and click Create Database. The database should be pending. And for Yakash, I will explain exactly what Astra DB is. And it's not DBMS, it's NoSQL, surprisingly, as the title of the session today. Yeah. But we will explain exactly the differences. Okay, so waiting for sum up in the chat then, and I can move on and give you a few insights about what is NoSQL before going back and actually using the database. Yeah, so still pending is okay, yeah.
Yep. That is actually what we want. If it's in pending, you're in a good spot. If anyone is running into any issues or needs me to repeat any steps, please let us know in the chat as well.
Yeah.
And the GitHub repo does kind of walk you through all the steps as well. So if you want to read through it, that is a good place too.
Status active. Okay. Congratulations, Ravan. Can we change the key space? Yes, you can, but all the exercises have been designed with this key space. So that means you won't be able to copy paste ad hoc all the predefined queries that we have done for you. You would have to change. So it's doable. We will tell you when you need to change, but using the provided one would be easier for you to stay up to date during the live.
Yep, and Raunak, any specific database name or key space name? In our GitHub repo, we do specify those. The database name will be workshops, and the key space name will be NoSQL1. Yep.
Yeah, and the video will be available on YouTube. Yes, it's recorded. So it will be the same link as right now.
Cool. Looks like most people are in pending. I haven't seen any issues yet. So
yeah, I've seen Navin, Bhavani telling us that it's starting. What should be DB name and key space? Yeah, it's really in the README. So really, so I can copy paste the values, right? But so the database name is workshops, and the key space is NoSQL1. Okay. Moving forward, you will have to copy whole block of code. So make sure you have these Git README open somewhere on your laptop.
Yep, it'll help a lot.
Okay, so you can still you can let the database initializing, and I will explain you a bit some concept regarding NoSQL. So Ryan, tell me when I do have the screen again.
You got it.
And oh, it seems like I don't see it on
It might
YouTube
take a little
right
while for
now.
it to update for you, but you do have it. You can go ahead.
All right. Okay. So here it is. Let's get rolling. So a database, first of all, is a software to save things and retrieve them later with queries. What a surprise. This is the end of the workshop. It was a great session, right? It's just a piece of software to save stuff. Of course, we will go into many details. So a database is not something monolithic like a piece of software you could expect. Inside a database, you have multiple components, multiple layers. So first layer you probably heard about is the interface layer, the one you use to interact with the database with some language. Is it SQL for relational database, JSON for MongoDB, binary cipher for Neo4j, and so forth and so on. Each database could have its own language, also its own protocol. For relational would be TCP, binary, ODBC, JDBC. You may have heard the term already. For others, database could be over HTTP, like Elasticsearch, for instance. Behind this interface layer, there is something reading your queries, analyzing your queries, and deciding in which order execute the part of your queries. This is the execution planner, parser, analyzer, dispatcher. This is what we call the execution layer. And finally, you find the storage layer. Sometimes the data are stored on disk, sometimes data are stored in memory with not the same guarantee, of course. Sometimes it's stored as binary format, sometimes it's stored as text. So any flavor of database, even two relational database won't have the same execution and storage layer. Okay, so that's the first things you need to realize. So that it's true for relational database, NoSQL database, all the database. Okay, so why NoSQL was invented in the first place? Why? Because relational database seems to dominate the world since the 60s. So why something new? Well, the usage and the requirements change. First, about the volume. Okay, more and more data to store, and relational data were not able to cope with so many data. Now the joins take forever to run. It's just too much volume, or too hard to do. Second is the velocity. IoT, 5G, all the new use cases you may find out is all about speed and a lot of message per second, and you can have millions of writes try to access your database. And unfortunately, relational database will also struggle to cope with so many requests per second. And the last piece, the last V, it's a 3V, is variety. We used to have only SQL, store table and normal form and relationships and integrity constraint. But this is not the only thing you want to store in a database. Sometimes you want to store JSON. Hey, hello, front-end guys. Sometimes you just want to store a binary or graph or a lot of type of data. This is also why big data is as been so famous as well, just to be able to store a lot of stuff. So to cope with these 3V, volume, variety, velocity, well, look at that. Look at all these requirements. So we used to be like, yeah, zettabyte. I don't think zettabyte is what, 10 to the power 18 or something. So that's just a huge amount of data, and it will go on the increase. So already today, relational database have struggled with so many data, and it will get worse and worse. So we need something able to address these 3V requirements, okay? The last issue, I would say, with relational database is they try to cope with all the use cases. Some use cases are real-time, what we call OLTP, online transaction processing, probably the one you are the most in use. Read and write in real time, the web service, web UI. It's all about online, right? Needs answer now, simple queries. Okay. But the same relational database are also used for OLAP, analytics, long-run queries. You may have heard about data warehouse, data mart. This is at the end of the day. You want to get some KPIs, some analytics, some dashboards, metrics. How many requests did I get over the day? Well, those queries can take a lot of time. The data model are different. It's what we call also BI, business intelligence. And the relational database also try to cope with that. So with so many things to do and so limitation, we need something else, okay? If you look here at the square on screen, you see that there is the domain where the relational DB is at ease. It can do a bit of everything, but as soon as you hit a limit, well, you cannot cope anymore. And this is why we need something else, okay? This limit, the idea is at some point, the relational database cannot keep up. Relational databases are at ease on a single machine, and often a single machine is not enough, and you need to scale out, add more machine. So not only SQL, so NoSQL does not mean it doesn't speak SQL at all, okay? NoSQL means not only SQL, okay? So that's the first things to realize. So those have been created by, no surprise, the web giants, so the GAFAM, the one that used so many data in the first place, so 10 years ago-ish, But now most company will have the same needs. The quantity of data has increased so much. And you can see in blue what the NoSQL database will be at is. So more throughput, more capacity, and coping with the 3V, volume, velocity, variety. So can the single host system handle all the three requirements I gave you? In short, no. It's a single machine, and you can scale out a relational database. So you can do something called sharding and install Oracle on two machines, for instance, to scale out, but it has not been designed for that in the first place. So it is spending a lot of time to synchronize the node one to each other. And it could be super slow to absorb, and not effective to absorb so many requests per second. The NoSQL system, on the contrary, has been designed for distributed system by default. Okay, this is how they have been designed in the first place. So in a distributed system, very, very important to realize, there is a theorem written by Eric Brewer stating that if something goes wrong on a distributed system, you cannot ensure at the same time consistency and availability. This is how you should read this diagram. Okay, as long as everything is okay, all nodes are consistent, the data is available. But then, if, I don't know, one node goes down for some reason, like a AWS region goes down, maybe it could happen, then what do? Some database chose to be consistent. Some database choose to be available, but it cannot be both. So if I told you about a NoSQL database, some database choose consistency. This is what we call CP system. And others database pick availability. This is what we call AP system. So availability and partition tolerance. So of course, you have an obvious question here. What is partition tolerance here in the schema? That's just a failure. Okay, partition tolerance, when I told you a node goes down, that could be just the machine crash, but it can also be you lose the network in between the nodes. Okay, this is what partition tolerance means. It's a split in the network. So if that happens, how does your distributed system react? It needs to choose between consistency and availability. So for a NoSQL database, even if do not talking about consuming JSON, table, or everything, at the core of the architecture, it will be different based on the choice that has been made by the designer. Okay, NoSQL are distributed system, cloud are distributed system. So what is exactly NoSQL? Well, okay, let's go for it. First slide to do some screenshot. So relational database, any database that support SQL, okay, and based on relational database. Okay, so names, Postgre, MySQL, Oracle, MariaDB, Aurora, all these databases. NoSQL, well, it's flexible. There is a lot of different choice. You can have tabular databases, document databases, time series, graph, key value. So it's not the same interface. They have not chosen the same execution layer. And each time there is different implementation under the hood. So for today, within this wide NoSQL world, we will show you 4 of them. Document, tabular, graph, and key value. The idea is really to work with you what they are good for, what are the choices they have made, and do a little bit of hands-on to realize how to use them. Okay. And I can see that some databases are now active. That's great. Okay. if I ask you to put all the NoSQL technology on a map, you can't do it. First of all, I told you there are hundreds of systems, so it's pretty hard to put on a map. This research group called 451 Research tried to put everything on the single map and just resign or stop doing it in 2014. Already there were too many. And 8 years later, you can say, okay, it's even worse. So instead of giving you a huge decision tree about everything that's possible, we will show you 4 big categories. And I've shown you that already. Column-oriented, document, key value, and graph. And see, we have put you some nice icons for you to kind of realize immediately what it does. Okay. Based on the technology, they pick different, they will have different behavior for integrity, consistency, availability. And this is what we will discuss now. Okay. So many databases, so many flavors, so many ways to use it. We won't ask you to install 20 databases today. We only have 2 hours. So the idea is to leverage on one column-oriented database. It's called Cassandra, here in the bottom of the screen. And in the web platform we are using, called AstraDB, there is a proxy on top of the database. It's called a data gateway. And the data gateway will expose you some APIs. And with those APIs, you can use the database as column-oriented. This is what it has been designed for, but also as a column-oriented database and the key value. And for the graph, we will use a Docker. Okay, so let's go over the different categories. I think we did that. You created the database already, right?
Yes,
so,
we did that.
I will just show you the tabular database. And with that, Ryan will walk you through the end zone. Wow. Okay,
all right.
So, I mean, just last slide and
oh,
you
yes,
go, right?
That's right.
Yeah. No, just last slide. So, yeah, a tabular database, as the name stated, surprisingly, store tables. Okay, but it's different from a relational database. Okay, the values in your tables are distributed across multiple nodes of your cluster. Okay, so if you look quickly at the pictures on the right part of the screen, immediately you realize, oh, if I do select star from this table, it will be slow because I will have to interact with every single node to gain one chunk of my data. And this is not what we want to do. What you want to do is always provide in the where clause the value in red here in the schema. Because if I want to list all the city in the USA, for instance, if I provide USA in my where clause, now the client will interact only with a single node, the one on top of the graph here, and it's way faster. So this is why you see the icon at the very top right-hand corner of the screen. You really need to design your tables with thinking about a key, a partition key that will decide how the data is distributing among the node. Could be called also sharding key, row key. It's all about splitting the data among multiple nodes. Okay, so if you have the key, then you can request multiple columns in the tables. It's column oriented, associated with one key. You do have multiple columns, but you need to shape your queries in a way that you know in advance what is a key. Okay, data is distributed as a key, data is stored on disk. When you query, you always need to provide the partition key. there are alternatives to do something else called secondary index, but it's a workaround, it's a trade-off. It will be slower in all cases. Okay. Also there is no joins. Look at that. If I want to join one table with another, all of a sudden, all the nodes will need to interact with one with each other, and it will be slow. Instead of joins, here we are using denormalization. You will have in the same tables the user and the group, and the table will be called user by groups. And if you want the group of a user, you will see a group by user. So it's denormalized. The joint is like already done when you save the data. You save together what you want to retrieve together. Okay, what are the big names of this tabular-oriented? Apache Cassandra, the one you will use right now. Google Cloud Big Tables, Amazon Key Spaces, HBase. And if you ask me which one is better, I will have a BS, of course. DataStax is all about talking about Cassandra, but each one have their own strength and weaknesses. So they have chosen availability or consistency. They are implemented these Java or other languages. And based on that, it won't behave the same. But still, the one we will ask you to use is used by the biggest. Apple, Netflix, Uber, all using Cassandra. And that database could scale so much, you have no idea. For instance, at Apple, they almost have 200,000 nodes of Cassandra. 200,000 nodes. Isn't that crazy? Okay, so with that, I think you are ready for doing a bit of hands-on, and I will come back just to close, explain you a bit of the use cases of that, and move to the next flavor of database.
All right, sounds good. So if you go back to your Astra dashboard, you should have your database is now active, which is good. And I am in the GitHub repo. I'm now on step 2, if you're following along there. And we're going to play around with this with our database as a tabular database. As Cedric said, AstraDB is based on Cassandra, which is a tabular database. The first thing that we're going to do is we're going to click into our database that's now active. And then at the top, there is a few tabs. There's the overview, health, connect, CQL console, and settings. Go ahead and click on CQL console. And that should open up a terminal here. It will automatically log you in. And we're going to run a few commands. And you can copy these out of the GitHub repo if you're following along there. That would be the easiest way to do it. I'm going to go ahead and do that just so I don't mistype anything. And the first command we're going to do is describe key spaces. So right now we're just in the database and we want to see all of the key spaces that we've created. And you can see a lot of system level key spaces. We have our NoSQL 1 key space here that we've created. If you are returning, you might have some from other workshops. We're interested in the NoSQL 1 today. So the first thing that we're going to do is run the command use NoSQL1, right? So that make sure that all of our commands are running in the correct key space. And then we're going to go ahead and create a table. Now, if you are familiar with relational databases like MySQL or Postgres, this is going to look very familiar. This is CQL, which is based on SQL in a lot of ways. It looks very familiar. There are some important differences, and we'll point those out. But it'll look very, very, very similar. So we're going to have a create table if not exists. So if it already does, we're not going to mess with it. We're going to name the table. And then we give it the column names and the data types. We have UUID, we have text, timestamp, so on and so forth. And then we have our primary key, which is our unique identifier. And then you can see that we have this column in parentheses. And this notation defines the fact that we are creating the video ID. We're defining that the video ID column is going to be our partition key. Now, Cedric mentioned that in a distributed system, we want to make sure that our data is spread around the cluster, and it's going to use that partition key to send that data around the cluster automatically. And so that's what that's how we define what the partition key is in these parentheses. So I'm going to go ahead and copy this command out of the repo and just paste it in here. So I'm using our NoSQL key space, and I ran that create table command. And so now we have a table. If we run this command, the describe key space NoSQL1, we can see the structure, and we should be able to see that we have our table here, NoSQL1.videos, and you can see all of our columns and data types, and a few other metadata here too. Okay, so now we want to insert some data into our table, and this will also look very familiar. Let me make this a little bit bigger so we can see the whole thing. This is very similar to SQL. Insert into our table name. We're going to define all of the columns for the values that we're entering, and then the values will show up right here. This is pretty much identical at this point. So I'm just going to go ahead and copy these out and paste it in. So now we've done 3 insert commands, as you can see. 310 mode Akram asks, is it case sensitive? No, it is not case sensitive, but just for readability's sake, it's customary to capitalize the commands. It's the same for SQL. All right, and so now we can run the select all from videos command. As you can see, it is not case sensitive. And if we run this, we can see that all of our data that we just entered is now in our table. And I'm going to make this bigger just so it's formatted correctly, or maybe try to. And so you can see our table here, right? We have our video ID, which is a UUID. We have our email, our frames column.
I think we do have a request to probably zoom in the SQL console.
Okay,
if you can.
Yes. Thank you. This is going to mess up my formatting again, isn't it? How big should I make it? All right. Hopefully that's big enough to read. Thank you. So the formatting is a little weird, especially at this resolution, but you can see that we have our columns here: video ID, upload, email, frames, URL tags, title, and then we have all of our data there. Akash, yes, I will slow down a bit. I need to switch between 2 tabs.
Only 2? It's just the beginning then. No, just kidding.
Yes.
Sometimes some workshop we do have 4 tabs. No. Today it's easy peasy.
Yep.
Just YouTube, GitHub, and Astra.
Ravan asks, what is UUID? Why is it used for video ID? So we are generating a unique identifier, a universally unique identifier for our video ID. So this is a command, a standard command that CQL recognizes to just generate that unique identifier to enter in. So this is what it creates, this mess right here.
It is. Also, it's different from a sequence in Oracle, for instance. To get a maximum of something in Oracle, you can use a sequence or auto increment in MySQL. Here in NoSQL, it's different. You want to each of your node to be standalone and do not share anything to be as fast as possible. So if you use UUID, it is a way to generate a unique identifier. Look at that. It's so long. There is more UUID than atom in the universe or something like that. And you can be sure that 2 UUID won't be created, two exact same UUID won't be generated. So it's a way to ensure unicity without the node to communicate to each other.
Yeah. Someone asked, or Partha mentioned that it's not allowing pasting. You can also right click
Yeah,
and select paste.
right click paste.
That usually works if your Control or Command V is not working.
Yeah, right click paste. That's the way.
Akash says, up till now, it's the same as SQL DB or relational DB. So far, yes, pretty much. I mean, this is a tabular database, which is very similar to most relational databases, right? So it's going to look very familiar. And because CQL is so similar to SQL, it'll be very familiar in that case. We'll start getting weird in a little bit, not weird, but different with some of the other examples that we have. I think the big difference with in this case in tabular is that we would use denormalized a denormalized structure rather than adhering to the third normal form, whatever, and being willing to repeat data so that we can prioritize efficiency and speed in our requests.
Yeah, and if you are stuck in the middle of a request or the request does not execute, maybe it is because you forget about the semicolon at the end of the request.
Yep, that is important. It'll give you a ... if it's waiting for it.
Yes, yes. So replication network topology, that's really key in Cassandra, as Ravan stated. So replication is how many times does my data is replicated among my nodes. There is no master in this architecture, and the data is replicated. The purpose to do that is even if you lose a node, it's not a big deal. The system will still respond and give you the data you expect. So replication factor is how many times my data is replicated. And network topology, we have shown you one ring in my pictures before. In Cassandra, you can have multiple rings. One ring on each region, for instance. And so you can read and write from everywhere, and Cassandra job to replicate the data on the multiple rings.
Yeah. So Aditi asks, can you explain what denormalization is again?
It's okay.
Do you want to take that, or do you want me to?
No, go for it. Go for it. It's 1 minute.
So denormalization is, well, so normalization is where you would create, you'd focus on not repeating data. So you would have a table for, say, users, and you'd have all the user information, and you'd have some kind of unique identifier for that user. And then if you have groups, you would have that identifier for the user in that group's table, and you would have if you wanted to get the users in a group, you would have to join those two tables together to get all of that information. If you wanted to get certain details about those users, that is the normalized structure, right? You don't repeat any data. With denormalization, because joins are expensive, and in NoSQL, in this database specifically, there are no joins. You need to use a denormalized structure, which means we're going to repeat data. We're going to have a table called users by group. And so we'll have a group identifier and then all of the user information in that table. And then we might have another table, groups by user, and we'll have a user identifier and all of the group information in that table. So we're going to have repeating data because storage is cheap at this point, and speed is really important. So we're not so concerned about repeating data as long as the data is fast to retrieve. Hopefully that answered your question. All right, so we have done the first selection. We selected all from videos, but this is actually kind of the wrong way to go about it. Alex likes to use the example of if you were to order a pizza and you didn't give the delivery guy your address, the delivery guy is gonna have to knock on every single door to see if they're the ones who ordered the pizza, right? you want to give, in this case, because we're in a distributed system where we have data on different nodes, you don't want the database to ask every node, hey, do you have this data? Hey, do you have this data? Because that's really inefficient. So you want to give the database the address, or in this case, the partition key, so that it knows exactly what node to ask for the data. So that's what we're doing here. Because we created this table with the partition key of video ID, like that's our column for the partition key, we're going to select all from videos where the video ID equals a certain, the UUID, right? So I'm going to copy this out. So if I paste this, it's going to be much faster. Obviously, we're working with a very small data set with only 3 nodes. The speed difference is going to be difficult to perceive in this example. But in this case, we are giving it that address. We're saying, here's the partition key. You know exactly which node to look for, or exactly which node to ask for this data. And it's much quicker and much more efficient. So what this means is that you need to design your data model in a way that you will always know that partition key. And that will allow you to utilize the distributed nature of the database to its fullest potential.
So the question coming regarding the partition key, but for now, in the video table, it's, video ID is really our primary key, just ensuring unicity. So you will really grasp the what a partition key is in the next sample with the user by city.
Yeah, and Akash asked to clarify what nodes are. So we are in a distributed database system right now. We have, with these Astra databases, you actually have a 3-node cluster, which is 3 separate machines that are all hosting that data. So, it's not a single monolithic machine that stores all the data. There's actually, in this case, 3, and in the case of Apple, 200,000, right? So a node is a single machine with the database is installed, or a single instance of the database. Okay. Let's move on. So we're going to go ahead and create another table. And this is going to look a little bit different because we're, the first example, we had a very simple structure. We only had 1 column as the partition key, and we didn't do anything with clustering columns. So we're going to talk about clustering columns a little bit. So in this case, we are creating a new table. This is called users by city. This is kind of a convention and of how to name these tables. So in this case, we are storing users' information, and we are partitioning by city. So just based on the table name, we kind of know, okay, the partition is going to be city. I need to provide it the city information so that it knows where to look, right? Then we have our column names and the data types, and then we're defining our primary key. Now, in this case, we have the partition key is wrapped in these parentheses, right? So we have city is defined as our partition key. It's wrapped in these parentheses. But then we have these other 2 columns, and what are these? These are clustering columns. And clustering columns do 2 things. First, they work in conjunction with the partition key to create the primary key. And the primary key is what defines a unique row, right? So if we're partitioning by city, city is not enough for to determine a unique row, because you could have, 10 John Does in Phoenix, Arizona, and the fact that that Phoenix is where they are isn't unique, right? There's too many of them. But if you include the last name, Doe, and their email, which their email alone should be unique enough, those 3 pieces of information together should identify a unique row, right? So they work together to create the primary key. The other thing that clustering columns can do is order data on disk. So in this case, we are defining the clustering order by last name ascending and email ascending. So what this means is the data is actually going to be ordered on disk and in a certain order, starting with last name ascending and then email ascending, so that when we read that data back, it will already be in a predetermined order. This saves a lot of effort on read if we don't have to use ordered by last name ascending when we read the data back, which is pretty expensive and can slow down our reads. We actually pay that cost on write, which is a lot cheaper. We can do things in parallel. It's a little bit more asynchronous. So it's a really powerful tool in this case. So I'm going to go ahead and copy this create command out and paste it in here. And so now we have that table, and I'm going to go ahead and insert some entries. Again, this is pretty simple. It's pretty familiar if you are used to SQL. But if you're not familiar with SQL, I'll go over it one more time. So we're inserting into a table. We're defining the table name. In the parentheses, we have the columns that we want to insert into if we want to insert into specific columns only. And then the values, we have the data in the same order as the columns that we listed here. So city will be Paris, first name will be Linben, last name will be Cedric. Those are actually backwards. Cedric's first name is Cedric. And the email is clu@sample.com. All right. And so now we're going to read this data back. So we're going to select all from users by city, and we need to provide it the partition key. So we're providing where city equals Paris. And so now we get our data back. And you can see that we only get the data that have the city as Paris, and it is ordered first by last name. So C's come before J's, and then by email as well. Rajiv asked a good question. The difference between primary key like this, or if we omitted these parentheses. So you actually need these parentheses in this case. This is what determines which one of these columns is going to be the partition key.
Yes, it's a tricky question because if nothing is provided in the SQL, Cassandra will consider that only the first column is the partition key. So in this particular use case, the double parentheses are not mandatory, but we highly recommend you to always provide double parentheses.
Yeah, there are some safety mechanisms in place, but it's this is standard formatting, and you would do this because there are ways to, and we would go into this in a more in-depth Cassandra workshop, which I think next week we're going to do. You can create partition keys with two columns, a composite keys, if you will. And then you are required to use the parentheses. Otherwise, Cassandra will default to the first one listed. So this is a convention. It's a important convention to get used to, because there are definite reasons you would use parentheses. Gosh, I wasn't panicking. I just I want to make sure I don't assume. Oh boy, that's funny. Okay, so that is the basics of a tabular NoSQL database or NoSQL database. We have created some tables, inserted some data, and gone over some basics of denormalization and the importance of providing the address of where your data is, that the database can be as performant as possible.
And could feel a bit tricky. Now is the time for self-promotion. So the workshop of next week will be 2 hours only on the internals of Cassandra. So if you want to learn more, subscribe to the channel and get notified next week, same time, for 2 hours only on Cassandra.
Yeah. All right. I'm going to send it back to Cedric. you've got the slides up. If you have any questions,
Yeah,
feel free to ask in the chat, and we'll address them.
It's really a good time for question interactivity. Akash asked question. Partition key should always be a subset of the primary key. It's a subset, yes, but sometimes the partition key can be the full primary key, nothing else. This is what we did in the first example with video ID. Video ID was the primary key and the partition key at the same times. What it means that in a partition for that table, you have a single record. And really, it's not a big deal. That's really a convenient way. There is nothing wrong with it. You want to save together what you retrieve together. If you put a UUID as your primary key, all the access you will do to that table will be get by ID, save by ID, update by ID, and that's totally good. There is nothing wrong about that. Okay, so if you look at my screen now, just the slide to explain you what would be the use case of the tabular oriented database. It's all about scalability. If you need more throughput, more capacity with this design, you simply add new nodes, and it scales very, very large. We told you about 200,000 nodes at Apple. I think Netflix is 100,000 nodes ish about that. It's 30 million queries per second. By the way, on this YouTube channel, you can find the technical leader of Netflix explaining exactly how we use Cassandra. The second point is all about availability. You have seen a parameter called replication factor. Your data is replicated on multiple machines, multiple servers. And there is no master. That means if you lose any of the server, the data is still available somewhere else. And so client can still use the data. And so it's all about available. So second good range of use case, way more available than relational. The system is AP. Remember, available in the CAP theorem. Distributed, so the data is distributed in a ring on 3 nodes, 3 servers, what we do today. But you can also have multiple rings across the world, and Cassandra, the same, will replicate the data on multiple rings. So the idea is to have the data as close as possible to your user to reduce the latency. You know, if you are front-end developer, you may have heard about something called CDN, Content Delivery Network. That's something that will save all your static files, image, HTML, CSS, JavaScript files to deliver them super quickly because they have endpoints across the world and reduce the latency. Well, Cassandra in a way is also distributed the data across the world and have the data as close as possible to your user. Cloud native, why did we talk about cloud native? Cloud native, it's associated with Kubernetes. Kubernetes like to scale out the pod, adding more pods to increase the capacity of the system instead of adding disk, adding CPU, adding memory on existing machine. Now the idea is here to be more flexible. You need more power, well, simply add new nodes. And if eventually you will need less power later, you can remove some nodes. But for databases, removing nodes is not likely to happen. There is very unlikely that you will delete a huge chunk of your data in the database. Okay, so second range of okay, that's great. That's it for the database tabular. Take a deep breath. Second database. So second range of database are called the document-oriented database. So the most famous name in these fields, MongoDB, Couchbase, and Elastic, even if Elastic does not consider itself as a real database. So here you will interact with the database not using table anymore, but using structures, object, JSON object in the case of MongoDB. So you might think about JSON statem. Okay, sure you will always remember now what a document-oriented DB is. JSON statem. And I like to say, I put this guy there because in document-oriented database, there is no rule, no schema, you know, JSON Stata, no rules. Well, it's what we call schemaless, because you can insert in the same collection, what we call collection, same area. It's not table, it's called collection. You can insert in the same collection two objects that are not really close to each other. They don't have the same fields, they don't have the same structure, and still you can put the both documents in the same collection. This is what we call schemaless. So MongoDB use that JSON and is very famous and in use in any front-end application, because front-end application use JavaScript. Everything in JavaScript is Java object notation. So under the hood, you still have already the JSON. So for JavaScript user and developer, it just, hey, take my object, take my variable, save into the database, and you don't have really to care how really it's stored. So these databases are good to request query either by the key. So when you insert something, you get an ID, and then you want to interact with the database using the document ID, or doing some filters on the attributes. Filters could be at the first level. So find me in the collection X all the document that does have the attribute movies, and boom, you got it. Or does have the attribute movies with the value, the expandables. Again, no, no relation with the pictures on screen. Fast and Furious and expandables. Okay, so here this is the way that you shape your queries. These systems are CP from as far as I know. So it's great for read because the data will be available on multiple replica, but for the writes, it will always be pointing to the master. So super effective to read, a bit less to write. For the use case, be careful. If it's just reading, hey, that's fine. If it's writing at low speed or normal speed, it's okay. And user interaction on the user interface is something that I call low speed. Okay. Previously on Cassandra, you could expect, I don't know, some sensor to give you a value every 5 milliseconds. That's totally fine. Here is not really the case. Number of write requests per second are limited. But still, with the document, you are flexible to put whatever document you like, and you're also flexible with the where clause. And with that, I think Ryan will show you how, using the same platform, Astra, you can interact with the database as a document-oriented database.
Yes. Yeah, so we're going to illustrate document databases using the same database, the same AstraDB, which is a tabular database. So how are we doing that? Well, in short, magic. But not really. So Cassandra, which is what Astra is based on, actually can handle JSON right out of the box. And to illustrate that, I have an insert here where we're going to insert into the video table, and we're going to define that this is a JSON object. And so Cassandra can support JSON right out of the box, and this is just defining, it has the column name and then the data for that column, just organized into a JSON object, right? And we can actually read the data out as a JSON object as well. So if I copy this, we're selecting and we're defining that we want the JSON object back, and we want the title, URL, and tags from videos. So if we execute this, you can see that we actually get a JSON object back, which is really cool. So Cassandra actually does support JSON right out of the box, but it is a kind of an interface to those tables. Now Astra includes on top of the Cassandra database, Astra has a tool, a data layer called Stargate, which exposes a few different APIs to interact with the data. We have REST APIs, GraphQL APIs, and then we have a document API, which allows us to use this tabular database as if it was a document database, just like Mongo or any of the other flavors. And behind the scenes, what it's doing is it's taking that document that you're sending it, and it's shredding it and storing it into tables in the backend, and then when you retrieve it, it will recreate that document dynamically. So it's kind of a cool adaptation, if you will. So we're going to illustrate that by using some of these APIs. The first thing that we need to do, though, is we're going to be using a tool called Swagger UI to interact with our data, but we need to authenticate that communication. So we need to generate an authentication token in our dashboard here so that we can authenticate that communication. So the first thing that we should do is, in your Astra dashboard, you have this section where it says current organization. It'll have your email. If you drop that down, and then you scroll down to organization settings, go ahead and click that. And you'll come to this page. Oop, don't go back. And you'll see a few different sections. We want token management. So I'm going to click on token management. And I'm going to scroll down, and we are going to generate a new token. Now, the role that we're going to select today is the database administrator role. And that's a pretty high level role. For actual development, if you're developing an app, you probably wouldn't use this. You'd probably use a more specific kind of lower level role. Database administrator will let us do all the things that we want to do today without any fuss. We are going to create tables. We're going to insert data, retrieve data, all that kind of stuff. This is just kind of the easiest path forward right now without fiddling with a bunch of settings. So I'm going to select database administrator as the role and go ahead and generate token. So if I scroll down, here's my token right here, this last one, the Astra CS one at the bottom. Now, if I navigate away from this page, I will not be able to get back here. I would have to generate a new token. So make sure that you save this, this token by downloading the token details. And that's going to download a CSV that you can reference later. It's not a problem if you have to generate another token, but it is pretty inconvenient to just have a bunch of tokens out there. I'm going to try and keep this window open, though, just to make it easier. So I'm going to open my dashboard in a new tab. So give us a thumbs up if you got through the token generation part, or if you need any clarification. Just waiting a little bit to make sure everyone's good to go. Akash has some questions. Looks like, Cedric, you are answering them.
Yep. I'm on it with David,
Awesome.
Lambert, and Alwar Pan as well. We are good on time, so let's take time to answer the questions. Yeah. So as you can see, it's different from Tabular. Now it's all about JSON. So probably something if you have a little bit of experience, MongoDB is the one you probably have encountered the most. But okay, now if I ask you the question, is a NoSQL database schemaless? What do you answer? Well, I will help you for the question in the end, to be honest. But hey, you pay attention, so you deserve it. So Cassandra does have a schema. In Cassandra, you do have a table, and the table does have column name with column structure. There is a schema. In the document-oriented, by default, there is no schema. And so is so-called schemaless. So is the database schemaless? It depends on the database. Some are, some are not.
So Akash, if you missed to navigate to the token, and this is for anyone else as well, there are two ways to do it. The easiest way is if you're in your dashboard, you have your database here called workshops. If you scroll all the way to the right, there's a menu button here, this ellipses menu. If you drop that down, it's a generate token button, and that will bring you right there. And you can scroll down and then select your role. All right. Let me minimize that. All right, so now go back to your dashboard. Now that you have your token, select your database, your workshops database. At the top, we're going to go to the Connect tab. Up here. And then we're going to connect using the API. The document API is already selected, which is great. So I can scroll down past this menu. And we're looking for the Swagger UI. So there should be a section called Launching Swagger UI. And you will get a link. Now this link is unique for each person. It's pointing specifically to your database, but you can click on this link. I'm going to open it in a new tab. I think it will automatically do that. But it will open this API tool. I'm going to zoom in. It's going to open this API tool. And so this is a kind of a tool to illustrate all of the different endpoints that you can interact with through this document API. So the first thing that we're going to do is we're going to create a new empty collection. So I think Cedric mentioned this is the documents are stored kind of in this logical collection of documents, and we need to create that. So we're going to find the one that has collections. We want v2 namespaces, namespace ID collections. This one right here, this blue line. So we open that by clicking it. You can see that it has an example of the fields that you would enter. If you click on the button at the top right, the try it out button, that will open up these fields so that we can enter stuff in. And the first thing that we need to do is provide the token to authenticate this request. So we're actually going to be pasting our token in a lot of these commands. So make sure you have that token handy to copy and paste as needed. So I've entered in my token, and now I need to provide the namespace. Now the namespace is the key space. Namespace and key space are kind of interchangeable in this case. So we want to store this collection in the NoSQL 1 key space. Oh, this is listing collections. My bad. I am in the wrong section. I need to create a collection, which is the next one down.
First.
Which is the next one down. Create a new empty collection in a namespace. Sorry, folks.
Okay, so during that time, super important question about next. Why do we need to generate a token? Capital letter, so most important. So it's an API. Now we're interacting with a REST API. You need a way to authenticate your user. You know, the API we are using is public. You can copy paste that URL of Swagger, give it to somebody else, and somebody else could access it. This URL is public. Those API are public. So if you don't want anyone to access your data, you need to authenticate the user. The token, also called API key, is here to ensure that your call is well authenticated. That's just the reason.
Yeah, that's the key thing is these endpoints are publicly visible. And you don't want just anyone getting your data. Okay, so now that I'm in the correct section, we are creating a new empty collection in a namespace. It's a green section. I've provided my token. I've defined the key space or the namespace that I want to create this collection in this case, NoSQL1. Does this need to be bigger? There we go. And now I'm providing the body. And in this case, we need to provide a JSON object with the key name and the value of the name of our collection. So in this case, we're calling it COL1 for collection 1. And so what this is going to do is create a collection called COL1. And then if I scroll down, there's a big blue execute button. I'm going to click that. And you can see that our server response, we have a 201, which is a success. Now, underneath that in Swagger UI, you will see a list of all the possible responses. So the server response is the one that we got. So we got the 201, which is good. And now we can see an example of all the possible responses. So if we got an unauthorized, you would get a 401 if it was a conflict, whatnot. So just make sure that that you're reading the correct response, and then you can compare it with the possible responses so you know what to fix. Okay, so we now have a collection, which is great. We're going to now create a new document. So before I navigate away from this, I'm just going to go ahead and copy my token again, because I'm going to need it in the next section. And I'm going to scroll up, and there should be, the second one down should be create a new document. It's another green section. I'm going to drop that open. And I'm going to click on try it out on the top right so that it opens up those fields. First field is our token. I'm going to paste that. I'm going to try not to move so fast. So I'm going to slow down a little bit. Namespace ID, we know what that is. We want to provide the key space that our collection is in so that we can find it. So in this case, NoSQL1. Oops, don't press tab. NoSQL1. And now we have a field for our collection ID. So we just created it. It's COL1 is the name of our collection, so we'll provide that. So this is just providing the key space and the collection that we want to create this document in. And now in the body, we need to provide our document, our JSON object that we want stored. So I'm going to go ahead and copy this out of the GitHub. So in this case, we have, our video ID, our email, title, similar data that we would have in that videos table that we created in the tabular section. But in this case, we're not actually saving it to a table like we did with the JSON example with the tabular. We're creating a document in a collection. So I'm gonna go ahead and copy that out and paste it. So now we have this object in here. And if I click on the big blue execute button down here, we should get back our server response, a 201. And the response body sends us back a document ID. Now, this document ID is a unique identifier that is generated by the API itself. I did not provide this. I did not define this specifically, but it did generate it for me so that we now have an identifier for this document as a whole, so that we can provide that. If we wanted this document specifically, we can provide that identifier. So this is just a UUID, as you can see, that was generated. So if you're following along in the GitHub repo, you'll see the expected output. Your document ID won't look like this. It won't be this exact UUID, so don't be concerned if it's not. You just want to make sure that you get this response back. Okay. So now that we've created a collection and we've created a document in that collection, we can do a few other things to show how we would retrieve documents. The first is just finding all the documents in the collection. So say we know the name of the collection and we just want all of the information from it. So there is a endpoint. First thing I'm going to do before I exit this section is I'm going to copy my token again, because I am going to need it. And then I'm going to close this. Now, the first section in our Swagger UI is the search documents in a collection. So I'll drop that down. So in this case, we are going to provide the collection name and just retrieve all the documents in that collection. So I'm going to provide the token, provide the namespace ID, NoSQL1, provide the collection ID, COL1, because we know the name of it. And then we can just click execute. There's a few other fields here that we could use. There's a where section where we can, retrieve certain documents where data equals a certain thing. So if you have a specific email, you want all the documents where someone has a specific email, we can do that. Certain fields, page size, which is how many documents you're getting back. By default, this tool only retrieves 1 or 2, but you can change the page size so that gives you more. But I'm just going to go ahead and execute, and this should return us in the response body. We should have our object that we inserted last time. And as you can see, we have our document ID that was generated last time here in the data. So if we had more than one document, we would have in this data object, we would have multiple IDs with the data underneath. But in this case, we just have the one.
Swagger, yeah. So Swagger is the framework used to generate the web client you see here. So yeah, this is what we call Swagger, also called Open API.
Okay, so that's cool. We are able to retrieve all the documents, but say we wanted a specific document and we had the document ID, which we actually have here. So the first thing I want you guys to do is highlight this document ID here. Hopefully it's clear which one I'm selecting. It's this UUID, and copy it. So now we have that document ID, and let's retrieve the same document, but specifying the ID. So if I scroll down to our endpoints, there will be a section called, on the right side here, you'll see get a document. It should be a blue section. I'm going to open that up. Click on try it out to open the fields. And I'm going to go ahead and skip down to document ID. So now we know the document ID. I have it copied. I'm going to paste it in here. And now I need my token as well. So I'm going to scroll back up and grab that token real quick. Okay, so we're providing the token, we're providing the document ID, and we have these other two fields that we need to fill out that we know already. NoSQL1 for the namespace, COL1 for the collection. Ravan says, everything is running successfully now, feeling good. More importantly, I'm getting it as well. That's good.
Cool.
I'm glad I'm explaining it well, and hopefully I'm not moving too fast. A lot of this is once you know some of the fields already, token, namespace, collection, it's going to be a lot of copy paste. Hopefully it's easy to follow. All right, so I'm going to go ahead and execute this request. And as you can see, we have our document again. The format, oh, come on, scroll. The format's a little bit different. We have our document ID that we requested up here, and then the data just has our object, just has our document. So that's another way that we can retrieve our documents. All right. So I talked about the fact that we can use that where section to specify which documents, what kind of data we want in our documents when we search a collection. So let's scroll back up to that first section called Search Documents in a Collection, which I still have open. Our token's already in here because we've used this endpoint already. We've specified our namespace, we've specified our collection, but now we want to give it a where clause so that it can search in this collection for documents that satisfy this, this filter. So we're going to use this. I'm going to just copy this part out of the GitHub. But what we're doing here is we're filtering by the email key, or the email field, I should say. So we're saying where email, we have this $EQ command, which is equals clunven@sample.com, which is the email that we're looking for. So this is going to get all the documents that have...
Wondering who wrote the tutorial in the first place.
Yeah. We're getting all documents that have Cedric's personal email in them.
I think it's not the correct one. Yeah. Okay. If I got a lot of emails tonight, I know that's on you.
Yeah.
Your fault.
Yeah, I didn't write the workshop. So I'm going to paste that in the where section here. And now I can go ahead and execute this again. And we should get the same, pretty much the same response, right? Because we only have the one object, but we can see that our server response is 200. It was successful, and we got that object. So this is a way to kind of filter out your specific documents, even if you don't know the document ID, but you know, hey, I know I want this, all the documents with this email. This is how you can do it. Something to note, now that we've done a couple, is what this tool is doing is when you provide all these fields here, it is building this curl command. So this is actually the command that gets executed once you click execute, if my mouse will work. So you can see that it has a endpoint here. This is your API endpoint. You've provided it some of this information as well. You have your NoSQL1 key space here. Let's see if I can make this bigger. So this part, you've provided it the NoSQL1 key space. So that's how it knows how to build this URL. You've provided it the name of your collection, which is part of the URL as well. And now it has the where clause. So you have where equals, and so this jumble, which is kind of hard to parse, but you can see the email equals clunven@sample.com. A lot of these, characters are ASCII codes now. Is it ASCII codes? I don't know what they are. And then you have your you are in the header, you're providing this Cassandra token, right? This is where it authenticates it. So this is the curl command that it generates when you fill out those fields. And then this is the response that it gets. So just to kind of clarify what this tool is actually doing. Yeah, I'm not going to be able to pronounce your name, but Duta asks, this is through your UI. Yes, we're using this tool to generate these commands. How do you do this in a real use case? So we have a few workshops that deal with real use cases. And we have a library. If you're using something like Node, we have a Node library. We also have SDKs for Java and do we have a Python SDK?
Yes, we do.
We have a Python SDK.
So those API are exposed. We are and public. We are using them through API to have a first feeling about how it works, how it's used. But then in your code to use it, use any HTTP client. And we have done the work for you in the SDK, wrapping all the HTTP client. Now, how to use it? As you can see, we are working with namespace, collection, document. So the way to use it is really saving some document, retrieving document either by ID or by property without really any concern about the schema. So. And as Ryan stated, we have a workshop dedicated on document API. I think it's a clone of TikTok. So, go on the YouTube channel, you see a TikTok clone, and the TikTok clone is built on these document API.
Yep. There's also one that goes over using Vue.js as a front end, and it also uses the document
Okay.
API. Yep.
I think the Nest.js as well using the document API.
Okay.
Yeah, so plenty of samples. Also, you can go to GitHub and look for the organization DataStax-examples. This is where you find them. Also, you probably in Astra, so go and Astra sample app gallery, and you see there are multiple samples there. You also have some tools to navigate through your data. You have some starters on multiple technologies. Yeah, so overall, a lot of samples. But if you have a precise question, again, reach out to us on Discord and we will give you the link with just the code.
Yeah, so what Cedric just mentioned, on your Astra dashboard, there's a section on the left side for the sample app gallery. You can go there and it'll open up this window and you can see a bunch of different sample apps that you can explore and kind of see how things were implemented in each of those. So really, really useful information there as well.
Yep.
All right. So that is overview of the document database, illustrating that we are storing these objects for later retrieval. There are ways to filter which ones you retrieve, but with that, I am going to hand it back to you, Cedric. You have the slides.
Yeah, very quickly, just to introduce number 3, which is the key value database. So as the name stated, on those flavor of database, you will only store a key and a value. So there is no more where clause or anything. The functions are very simple. Put, get, delete, all based on the key. That tends to be the fastest because there is no real logic intelligence there. It just, hey, find the key and the value close to the key and you're good with that. So the most famous database on that are Redis or anything related to distributed cache. So you can think about Hazelcast, Memcache, Infinispad, Aerospike, all these distributed caching mechanism. DynamoDB also consider as a cache. And for today, again, don't want you to install a new database. You can set up a table in Cassandra with just a single column, and then you will have key, value. The value is your single column. Okay. So yeah, I think we can move to just the demo up front. And yeah, we need to catch up a bit of time anyway. So let's do that.
Okay, so I'm going to demo the key value database. So what we're going to do here, I'm gonna go back to my dashboard on this side. Man, these windows are huge. Is we're going to illustrate the key value database style using another one of the APIs that Astra with Stargate exposes. It's the GraphQL API. GraphQL is not at all required to use key value. It is just a way to kind of show another way to interact with data in general. So we're not going to dive too deep in how GraphQL works. We have other workshops for that if you are interested. But it is kind of a primer or a first look at it. So in your dashboard, I'm going to click into my database. I'm going to go up to the Connect tab, and I'm going to select the GraphQL API. And I have to scroll down because my window's super big. And we're looking for the Launching GraphQL Playground section. So the GraphQL Playground is the tool that we'll be using. It's similar to Swagger UI in that it allows us to utilize these APIs in a tool form. And it opens this up. Now, just a really quick overview of how the tool works. There are 2 tabs, GraphQL Schema and GraphQL. The 2 tabs do different things. So GraphQL Schema is where we would create tables or define our schema, any of our DDL commands, if you will. GraphQL is where we would insert data or retrieve data, so any of the DML commands. So it's important that you do the correct commands in the correct tabs. Just a sometimes a hurdle for folks who are unfamiliar with it. So the first thing I'm going to do is in the first tab, the GraphQL schema, I need to authenticate the communication with our database. So under HTTP headers at the bottom here, I'm going to open that up, and there's a spot for our Cassandra token. Now I am going to steal it out of my Swagger UI window because I still have it open and I know where it is. So I'm going to copy my token from here, go back to my playground, and replace populate me with my token. So once I do that, you can see the errors go away and we are ready to go. I'm going to close that for room. All right. So the first thing that we're going to do is we're going to create a table. Now in GraphQL, anytime that we edit data or make changes, it's called a mutation command. So you can see that we have a mutation. We are running the command create table. We're providing the key space name, in this case, NoSQL1. We're naming the table with the table name. So in this case, we're calling it key value. And then we're providing the columns. Let me make this window. Can I make it window? Okay, here we go. That's as big as I can get it. I'm gonna shrink this down. Okay, so we're providing the columns. So we are providing a partition key, because remember, under the hood, this is Cassandra. So we need to provide the partition key for it to distribute the data. We're giving it the name key as the column name, right? Because we're just doing key value. So we're gonna have two columns basically. And then the values, which is the other column, will be value. So super basic. So this is creating a table with two columns, key and value. Go ahead and click the big play button, and we should get back the name of our mutation, which we defined here, as true, which means this was successful. We now have the table with key and value. We can use the SQL console. I'm going to skip this just in the interest of time. We could go back to our SQL console and run these commands to see that it exists there. In the interest of time, I'm going to trust that it exists. And now we're going to enter some data. So because we're inserting data, we need to use the other tab, this GraphQL tab. Since this is a different endpoint, we need to authenticate it again. So HTTP headers will need the token as well. I'm going to copy that out of my Swagger and paste it. But we're still having a server cannot be reached error. And the reason is by default, the GraphQL playground points to the wrong key space. I'm going to make this big. Go to the end here. And as you can see, it's pointing to system. We actually need this to point to NoSQL. Oh, excuse me. We need to have this point to NoSQL1. So edit this URL in the tool itself and replace the last part, system, with NoSQL1. So it's pointing to the correct spot. And now when I click out of it, you can see our error goes away. All right. Hopefully that was clear. I am moving a little bit fast because we are running out of time. So if you have trouble keeping up or following, just feel free to just watch and learn from watching, and you can do this as homework later as well.
It's okay. In the homework, we will, be happy with some Swagger screenshot. No need for the playground screenshot.
Yeah. All right. So I just copied this query out of the GitHub repo, pasted in here. The colors might make it easier for us to parse this. So because we're inserting data, it is a mutation. That is a GraphQL command. We're naming this insert to KV for insert to key value. And we're actually doing two mutations here. We're doing two inserts. The first one we're calling key1, and we're running a generated command called insert key value. Remember, the table that we created was called key value. So this command, insert key value, is the command that we use to insert into that table. And in our values, we're providing the value for our key column and the value for our value column, right? And then we're doing the same thing for the other mutation. We're just changing the key to key2. So if I run this command, you can see that it's returning those values, kind of confirming that those were entered. All right, so I'm actually going to move over to, I'll just illustrate this. Don't feel like you have to follow me on this one. But I am going to run this command in the SQL console so that we can see that it worked. So I'm going to select all from key value, and you can see that we have key 1, key 2, and the values that we inserted. BBBB. All right. So going back over to the playground, I'm going to insert another, I'm going to use another mutation, and we're actually overwriting the entry for key 1, right? So we're providing the key 1, and we're providing a new value. Now this is still an insert, because inserts are considered, they're called upserts, right? So we're updating, an insert will update anything that has the same key that you're providing. And then we're requesting that the key and value are returned. So if I execute this, you can see that we're returned the key 1, and the new value CCCC. So if I execute my command in the SQL console again, you can see that the value was updated. So pretty simple. You know, key values are literally the 2 columns, key and value. They're very fast. And like Cedric said, there are no where clauses because you're just going to provide the key all the time.
Mm-hmm. Yep.
All right. So I'm going to hand it back to Cedric, who will walk us through the last.
Yes. So, and I will do quickly, just not to be too late. We commit on 2 hours. Would like to be late by more than 5 minutes, and we still have the game to play. So quickly, the last piece, and this one is all about demo and not at all about hands-on. So you can relax now, get ready for the game. So it's the graph database. Okay. So in the graph database, the data is stored, no surprise, as a graph. You will have some nodes having some properties, and some edges also having some properties. The idea is, with a relational database, if your dataset is highly connected, so a lot of joins one to each other, well, your queries will be slow. You know, as soon as you need 4, 5, 6 joins in the same SQL query, yeah, you know, it's exponential. That gets slower and slower. Graph database really are there to cope with highly connected dataset. A join in a graph database is like moving from one node to another. Super easy, complexity minimum. They have been designed to do so. So what kind of a dataset we are talking about? Social network, customer 360, Internet of Things, network, could be useful for recommendation and personalization. Find me all the book that I've read. Okay, boom, that's the first request. And I put a notation of 4/5. Boom, okay, I get all the books that I've liked. Nice. Find me all the same people that I've liked the same book as me. Okay, second range for the graph database. Then I find all the users that have read the same books and also rated high. Who are there? There are people that like the same books as me. And again, yet another graph move. This is what we call a path. Find all the books that the users that love the same book as me have rated with a high note, but I have not read myself. And here now all of a sudden you have a recommendation engine. Find me the books that I should love based on others people that love the same things as me. And it's no more complex than that in a graph database. So another way to interact with a graph database is called Gremlin. And here you do have a sample on the right part of the screen. And that's really navigated the graph find me a customer, then moving to address, moving to street dynamically. Okay, maybe 1 minute demo. I think I still have time to do it. So it's part 5 of the hands-on. You will be asked to start a Docker compose, so a database, a graph database, and something called the Studio, which is exactly what I do have here. It's a notebook-oriented tool like Jupyter Notebook or Apache Zipline. You may have used that at school. So first, what I'm doing, I'm creating the, oh, it's pretty small. So let me make that bigger, I think. So first things, what I'm doing is I create the vertex, the node of my graph. Then I create the edges. And as you can see, so the node, a god, a demigod, a human, a monster, okay, that's the Greek mythology. And in between the nodes, what I will have is father, mother, all the family relationships. So here I will add some custom index just to be able to search in all the direction. Here I provide a data set. So add the god name Titan with the age pretty old. Okay, so here I'm just adding the vertex. And after that, I'm adding the edges. So how those nodes are connected once to each other. Okay, the idea is just to say, hey, find me all the node, god, demigod, find me everything on the graph. And this is what it looks like. Pretty ugly, right? Well, with the same exact query, you can have a view now, and this is why you love, right? You can see the database as a graph. So here we have entered some location. Now it's here with the icon. I do have some here. This guy, look, it's if I click here. So this guy is a god. Here is Neptune. So Neptune lives in the sea. Yeah, of course, that's kind of Poseidon. Here we do have, it's the brother of Pluto, and it's battle with Jupiter. And as you can see, each edge can have some attributes, and each node can have some attributes. So that's pretty cool demo and pretty cool as well to use. You would use the graph database when your dataset is highly connected. So in a nutshell, with what we have seen so far, relational are good for a bit of everything. OLAP, OLTP, joins, consistency, transaction, ACID transaction. But if you add more throughput and more capacity, you cannot scale as much as you want. You need extra database, NoSQL system. We have shown you a document-oriented, MongoDB, the tabular-oriented, and the key value that's probably the most performance because super simple. The graph is there. It's even more relationship-oriented than the relational database themselves. And the sample I've just shown you is based on Cassandra. So it does have the same scalability as what I've shown you to Cassandra. Okay, that's the overall pictures. Now it's, we do have time for game, okay? Or, and I can still take your question afterward here or in Discord. Okay, so play with us with the game. Oh, what everybody was waiting for. So thank you for staying with us up to now. So to reward you, let's play a game together. So again, answer correctly, enforce fast to get more points. Make sure to look at your phone or your browser. This is where the question will appear first. We do have a delay about 5 to 10 seconds on YouTube. So make sure to use your phone just to avoid any delay and be the first to answer our question. Okay. So moving to the screen, waiting for players. So how many are we? We are still 100 staying to the end. So thank you if you enjoy the content. Consider to subscribe. And now it's a good moment not to miss any new session. Next week, intro to Cassandra, then 2 weeks vacation. And in January, we are back with a full boot camp with a Cassandra certification at the end. 4 weeks to build an app. Week 1, intro to Cassandra. Week 2, Cassandra data model. Week 3, Cassandra application development. Node, Java, Python. And week 4, API and microservice. And after 4 weeks doing the homeworks, you will get ready for the certification. How is that? So again, subscribe and not to miss that. Okay, now is the time to play the game and give you the swag today, not in January. Okay, let's get rolling. Are we ready? I see 56 player, 97 on screen. I can wait just 1 more minute. So again, to join the game, we have gave you the instruction in the YouTube. So menti.com 89 14 26 17. 758. Okay, so it's not moving anymore. Almost 60 people playing. So now you know the competition is with 60 players, and only the 3 fastest among you with the proper answer will get the swag shipped to you. So everybody's ready?
Let's do it.
I will start in right now. So 3, 2, 1. Good luck, everyone. What is Astra? It's a local in-memory version of Cassandra. It's a development tool. It's Cassandra as a service in the cloud. It's a movie with Brad Pitt. Yeah, most of you have it correctly, but you know what? It's also a movie. Oh, that's funny. So it's not a development tool because it's a real database, okay? Not only developments, and it's not in memory at all. That's really a real database with 3 servers you used today. Okay. Who was the fastest? I love now. So you will, look at your name on the screen and see if you were the fastest. Okay, so Sushang G96 is the fastest. William Shu, Siu number 2. Akash Ja number 3. Yeah, good job, Akash. You ask questions, now you're totally up to date. See, you should ask questions during the session. Okay, question number 2. So 8 questions total, okay? So stay up to the end. Question number 2. In a distributed system, you can't have at the same time a working and non-working system, consistency, availability, and partition tolerance, CA or CP or AP. Don't worry, be AP. So there is something you can't have at the same time. Yes, and it's the second solution. You can be CA, you can be CP, you can be AP, but you cannot be CAP at the same time. A working and not working system, now it's not a Schrödinger system or a quantum or qubit system, true and not true at the same time. Okay, keep moving. We have 8 questions to go. So, okay, so let's see. So seems like Sushan was again the fastest. Oh, no change on the leaderboard. Okay, so keep moving. Question number 3. And for fast to get more points. You need a distributed cache to store simple values. What do you use? So distributed cache. Column-oriented, key value, relational, graph, document, or you take another chance. Yep. So the distributed cache is really the simplest, is key value. Again, most of you have it correctly. Okay. All right, so Vicky and Rajo are now in the leaderboard. Okay, let's go for question number 4. You need to store and retrieve JSON document from an ID. What can you use? Document, column, relational, graph, key value, or another chance. You know, the answer will look like one to each other. Yes, JSON documents are for document database. Keep moving. Oh man, this shoot on G, always the fastest. You can't beat in.
It's
wow,
impressive.
Okay, impressive. So Vicky number 2 and Dragonite number 3. Question 5. Your dataset is highly connected and all focus on relations. What do you use? Relations. Column-oriented relational database document, key value, graph, or an aspirin.
At this point.
It's too connected. Let's take an aspirin. Okay, so in this one, it's the graph database. It's the graph database, highly connected. Okay, let's see. Hey, this time William Sue, what fastest? Okay, nothing is done yet. Akash coming back, still number 5. You know, still a way to go. Question number 6. What is Stargate? It's a TV show. It's a new Mario game. It's a gateway to the star. Or it's a data gateway to give you REST GraphQL APIs on top of Cassandra. Hey, it was also a TV show. But yes, Stargate is really the proxy we use on top of the database to play with GraphQL document API today. Okay, I think 2 more questions to go. Oh, look at that, so close, everybody. This question was too easy. Oh, Suchan just went to the number 4. Oh, wow. But yeah, again, still 2 questions to go.
Yeah, Akash is working their way back up too, which is cool.
Come on, no favorite, no favorite.
Sorry.
A NoSQL database.
That's a lot of questions.
Okay, everybody who got this question wrong is immediately eliminated. Man, I have answered this question so many times today. Oh no! How can that be correct, man? No, so 20 of you did not watch the workshop, that's for sure. We took multiple minutes to explain that in the middle of the workshop. Okay, so no, some databases are schemaless like MongoDB, some are not, like Cassandra does have a schema. Anyway, not a big deal. See who
who's paying attention.
Yeah, who paid attention? Okay, all right. Not a lot of movement, but you know, nothing is done. Let's see. Last question.
Last question.
Ooh, suspense. You need a scalable database with heavy reads and heavy writes. Which one do you pick? Which one haven't you picked so far? Column-oriented, graph, document, key value, or another chance? You know, you can eliminate one solution each time, you know, say. Graph, we did that. Document, we did that. Key value, we did that in the first question. Yeah, only the column-oriented remains. Yeah, so Cassandra, HBase, all column-oriented is all about every read, every write. You need more capacity, more throughput. You scale by adding new nodes. And with that, let's see the final result. So 3 top will get the swag. Okay, so congratulations, Surah, Vicky, and Sushant. Please make a screenshot of your screen just to prove you are one of our 3 winners today. We tend to have more winners than 3. And send an email to jackfryer@datastax.com. I will give you the email right now. And if you have already won this game in the past, please say it so, and we can make another winner, because you know we won't ship swag to the same people twice. You know, that's legit to make everybody wins. And you know, if you missed by just a little, come back next week and we will play another game, this time with Introduction to Cassandra. I leave this open. Okay, there's just a question: what should we do to improve this session? Did you enjoy it? And in the meantime, because you attended the session, I do have, so that's the email where for the winner to send their screenshot. Okay, it's recorded, so you know you can still pause the video and note. The homework, don't forget to complete the homework to get the nice badge. We have some users already with every badges, like 17. And you know, each workshop is a new topic, it's a new badge, and that's great to show. And soon enough, next week, probably next year, probably, if you collect multiple badge, you will get a reward. You know, that's if you complete multiple workshop with us, of course, you deserve a reward. Okay, did you know that DataStax sponsor your education and certification? Okay, that will be super true in January with dedicated courses. But hey, if you feel you can start doing some online courses, here is a link to claim a voucher for having the Cassandra certification. To take the Cassandra certification, instead of $145 for the attempt, you can try for free. But this workshop is of course not enough to try this certification. You need to go to academy.datastax.com, where you take free courses. Okay, everything's free today. Free courses, and based on the certification you want, you do all the courses. When you feel ready, shoot us an email and we will give you a voucher to pass the certification. But there is no real value to try it right now without doing the work. It's not an easy certification, otherwise it won't be a certification. But you know, congratulations, here you can try it for free. And with that, time to wrap up. We are a bit late, but you know, hope you enjoyed the session. To know what's coming next, best way is to subscribe to the channel, but you can also go to datastax.com/workshops and you can register to the incoming session. 2 sessions coming next week: Introduction to Cassandra. In 2 weeks, how to build an e-commerce application. Then pause 2 weeks, and we will come back in 2022 for a boot camp.
Yeah,
that's our Discord, of course. Talk that. And with that, I'm done.
All right. Thank you, everyone, for joining us. Hope you had a great time and learned a lot. Next week, we have our introduction to Cassandra, where we will dive deeper into how Cassandra specifically works. So join us for that. In the meantime, take care and have a great weekend. See ya.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them